Now here you have a cylindrical container, right? Let me just try to draw it. It's something like this, okay? And at this point, you have a hole, right? And then you have some liquid, some water inside, maybe some liquid, some water, and something is going to come out, right? And the valve has an area A to something like that. And this you have H over 5, and this one you have H, right? And then you have a piston here, and you can put a mass on top of it. So what mass would you put so that you can actually double the speed come out here, right? Well, I think one way we can solve this is to make use of Bernoulli's law, right, which says the pressure at this point, let's say the pressure at this point, P, the pressure at this point, P plus, or in other words, according to Bernoulli's law, the pressure P plus rho V squared over half plus rho G H. The height H must be a constant, right? So if we plug, it must be constant. Now at the top, you don't have speed and you have a height. So we find you have a pressure, which of course is given by the mass, right? So basically the mass will generate pressure, which is given by mg over A1, right? So that's the pressure general mass. And this pressure plus rho G, now the height is actually from here to it's 4h over 5, right? And this must be equal to the velocity at this point. I call it rho V squared and plus, well, that would be it, actually. The H at this point we assume to be 0, and that's velocity, and there's no the pressure at this point also 0, the pressure difference, right? So this gives actually the equation for V squared, right? Now you want to double V squared, and you can easily work out how much you need to change the mass, right? You want double V squared. What you need to do is just to increase this by square root 2, right? I mean, increase the left hand side, increase the left hand by square root of 2, right? That much. So it means that mg over A1 must be equals square root of 2 minus 1 times rho GH 4 over 5, right? So this equation determines the mass you need to put.